So today's topic is JDBC basics. So these are the topics that we are going to cover. We will talk about what is JDBC, and then talk about the concept of database URL, and then we're going to actually build JDBC application step by step. We'll talk about the concept of prepared statement and callable statement, and then transaction isolation levels, and then concept of data source. Okay, so what is JDBC? So JDBC is a standard Java API for accessing relational database. So through the API, you don't have to know the detailed information in terms of how you can actually make a connection to the database and how database in fact works. You are working with JDBC APIs. So it provides a portability of your application. You can work with any database and you can just use the JDBC APIs. So it's part of the Java SE, and the latest version of JDBC is JDBC 4 from Java SE 6. So JDBC API is a Java API. So by the way, JDBC API is a set of Java interfaces. Okay, so it's not Java classes. So when we say JDBC API, we are talking about Java interfaces. Then these interfaces are implemented by vendor-specific, meaning database-specific JDBC client drivers. So when you are using JDBC APIs, you're working with a Java interface, but the actual implementation of those interfaces are provided by vendor-specific, the database drivers. So majority of JDBC APIs are located in Java.SQL package. So the ones that you're going to see today are mostly in Java.SQL package. For example, data driver manager class, connection class, resource set class, and these classes. The only advanced functionality exists in Java SQL, Java X extension.SQL is data source. Okay, so again, we'll talk about the concept of the data source at the end of today's presentation. Okay, so what is JDBC driver? It's a database-specific implementation of JDBC interface, as I talked about in the previous slide. So every database has a corresponding JDBC drivers. So MySQL has MySQL version of JDBC driver, which is implementation of JDBC Java interfaces. And you have Java DB version of the driver, and that is again implementation. That's a collection of implementations of implementation classes of JDBC API Java interfaces. You can actually see all the client drivers and get those drivers from the website of this. Okay, so let's talk about database URL. So database URL is used to make a connection to the database, and database URL you specify the server, port, and protocol information. So the format of database URL is like this, JDBC colon, then you can have a database specific subprotocol, and then server location, typically is the name of the host and the port number, and the database name. So you probably have seen MySQL version of JDBC URL like this. So you have JDBC colon, and then MySQL, that is MySQL specific, the protocol. And then you have the server location, again in this case is localhost and the port number is 3306. And then my database, this is the name of the database. For Java DB version of the URL, look pretty similar. So JDBC, and for Java DB, the name you have to specify is Derby, and then localhost and port number is 1527, and in this case, sample is the name of the database. Okay, so let's see how we can build JDBC application using JDBC API. So these are the steps that you are going to follow. First of all, you are going to get database-specific JDBC driver. So if you are going to use MySQL, you have to get MySQL JDBC client driver. If you're using Java DB database, then you are going to use Java DB version of the JDBC driver. And then you are going to create a connection object. And then from the connection object, you get statement object, and then you can create the statement object from using the statement object. You can actually execute queries or you can perform updates, and then you can get the result. You can also get the metadata of the database and as well as the result set, and then you can close statement and connection object. Metadata is actually typically optional step. So let's take a look at each of these steps in a bit more detail. First, load database specific database driver. So in order to manually load the database driver, and register with a database driver manager, that is in fact the driver manager object, you can actually use the class for name, and then you provide a name of the driver. So in this case, I am loading MySQL driver. Okay, and once you call this one, that means this driver will be managed by the driver manager object. Okay, so once you have the loaded database specific driver, then you can get the connection object. So here, driver manager class is responsible for selecting a database and then creating a database connection. Now, as you will see later on, usage of data source as opposed to usage of driver manager is a preferred means for getting a connection. And the reason is data source provides connection pool schemes. Okay, so we'll talk about these things later on a bit more detail. For now, we are going to actually use the code of usage of driver manager. Okay, and the way that you are going to create the database connection object is from driver manager class, and then you're going to call the static method of driver manager, and then you provide URL, database URL, and then the username and password. So once this is successful, you get the connection object. Okay, and if there is a problem, then you will experience SQL exception. Okay, so once you got the connection object, then so this is just a review of the class and the method. So driver manager has get connection method, which we just have seen in the previous slide, which takes the URL, database URL, and username and password. And from the connection object, we can create a statement object by calling create statement method. You can also call close to close the connection. And then we're going to actually talk about the transaction behavior later on. From the connection object, you can set auto commit and rollback. Okay, so we'll talk about this one later on, so don't worry about this. Okay, so for now, I want you to focus about the fact that connection object is used to create a statement object. Okay, so now that's the next step, creating a statement object. So the way that you can create a statement object is by calling create statement method of connection object, and you get the statement object. Okay, now you are going to set your statement object with a string that is actually SQL command. Okay, so let's see that example. So now you are ready to execute the query or update, okay, or delete. So here, from the statement object, you are going to call execute query, and then you provide SQL query command. So in this case, I am performing a select operation from this table. Okay, and then it will result in the result set object. Okay, so it will perform the query operation, and the result is going to be captured in the form of result set object. As for update, you are going to call execute update method as opposed to execute query method. So this is for performing query, and this is for performing update. And then you provide SQL update command, and then it will return the success or failure. Okay, so now reading results is again, when you perform the query operation, the return value is going to be result set. So once you got the result set, you can iterate it to read each rows. Okay, so once you get the result set, you can easily access the data by looping through it. So the iterator is initialized to the position below the first row. So you must call next once to move it to the next row. So you have to call rx next, okay, so that it will be the first row, okay. And and then you can actually call get string or get int. So you're going to actually call get and then type, and then you specify column index. So column index starts from 1, okay? So you do not want to use 0, then you will actually experience an exception. So you want to use from 1. So I'm saying the column 1 type is a string, so I'm going to call get string method of the result set item, and then I get the value, string value. This is for column 2, okay? So I know column 2 is int, so I'm going to call get int for column 2 value, and so in this case you can actually also specify the name of the column as well. Okay, so continuation. So when reading data from the result set, use appropriate getXXX method. So basically, these are the types defined in SQL type, okay, types. So it could be string, int, double, object, or whatever, okay. So again, and you specify the column, the index here, starting from 1. Okay, so you can also read result set metadata. So this is typically optional things you do. So, metadata is in terms of how many columns you have, names, and the type of the column that was actually returned. Okay, so from the result set metadata object, you get metadata such as column count and name and type of the column. So this is an example. So you can call get metadata method from the result set object, and you get the result set metadata object. And so you can get the number of columns by calling get column count. So this is number of columns. And then you can actually iterate, for each of that column to display the name of the column, type of the column, and the precision information and scale information and things like that. Okay, so you can also read database metadata. So you can call the get metadata method from the connection object, and then you can get the database metadata information. So there are a lot of information, meta information about the database. Moving forward, prepared statement. For those of you who don't know the concept of prepared statement, I recommend you to take a look at the MySQL course of JavaPassion.com. Here we're going to just kind of glance how you can use prepared statement in JDBC API perspective. So what is a prepared statement? Is represent a precompiled SQL statement, SQL command. SQL statement is precompiled and stored in a prepared statement object. And then this object can be used efficiently to execute this statement multiple times. So it's used for efficiency reason. So let's say I created prepare statement from this SQL command. Okay, so I call prepare statement method of the connection passing SQL command, and I get the prepare statement. And then I set the parameters. In this case, we have 2 parameters, right? Salary and the ID. So I'm going to set, this is the position, and this is the salary information right here. I'm setting salary with the 100,000, and here I'm setting ID. This number 2 means second position, and this is ID, and then I will perform execute and update. Okay, same thing of this. Okay, so that's prepare statement. Callable statements is used to execute stored procedures, SQL stored procedures. Again, if you don't know the concept of SQL stored procedures, I recommend you to take a look at the MySQL course contents, where we talk about stored procedures and stored functions. So callable statement object contains a call to a stored procedure, and it does not actually contain the stored procedure itself. Okay, stored procedure is supposed to be maintained on the database itself. The first line of the code below, so we are actually taking a look at this code. So this is the way that you are going to call stored procedure called the show suppliers, and so you are going to actually call prepared call and provide the stored procedure the call syntax, and then what you get back is a callable statement, and then you can perform the execute query operation against with that callable statement. Okay, moving forward. So this is an example of usage of callable statement. Okay, so here we set the int and then register output. So this is set int in parameter, and this is out parameter, and this is a way you can set in and out parameter, and then you can register int in and out parameter like this, and then you can execute the statement with no return value like this. Okay, and then you can get the in and out. Okay. Yeah, again, if you're not really familiar with the callable statement, or stored procedures and stored functions, the concept, yeah, take a look at the MySQL stored procedure presentation and hands-on lab. Okay, so moving forward, so yeah, so this is the stored function. So this is the event list, and so basically, we are creating event list the function here. And let's see, moving forward, transaction. So I'm sure everybody knows the concept of transaction. So transaction from the JDBC perspective. So committing of each statement is transactional. By default every statement is transactional, but the committing each statement in transactional manner is very time consuming. Okay, so what you want to do is you want to actually have several operations to be performed in a single transaction. So in order to do that, you have to set the auto commit to false. Okay, so if you, as a default, auto commit is true, that means every statement is transactional, meaning every statement, new transaction gets started, and the statement is performed, and then transaction is closed. Okay, but so if you want to actually have a multiple operations to be performed in a single transaction, you have to set auto commit to false. So by setting auto commit to false, developer can update database more than once and then commit the entire transaction as a whole, meaning multiple operations as a single transaction. So if each statement is dependent on the other, the entire transaction can be rolled back and the user is notified, meaning the set of operations, the SQL operations will be performed as a single transaction. Okay, so these are JDBC APIs as far as the transaction behavior is concerned. So you can actually set auto commit either true or false. Okay, and so as a default is set to true, meaning every statement, SQL statement, is performed in its own transaction. Commit is the committing whatever you have done. All the operations that have been performed will be committed as a single transaction. So of course it's relevant only when you set auto commit to false. Okay. So in this case, commit operations performed since the opening of connection or last commit or rollback calls, all those things will be committed as a single transaction. Rollback is again when set auto commit is false, and it cancels all the operations performed again after last commit and rollback. Okay, so this is an example of transaction. So here I'm actually setting auto commit to false, meaning I want to perform my own transactional behaviors. Okay. So here, if I want to commit what I want to do is basically I perform all the operations. Let's see. Yes, so here I perform, I create a statement. So I insert into orders. So insert a row into orders. Okay, and then and also I'm also actually performing the prepare statement execute. Okay, so I did perform two operations, right? Two SQL operations, and then I commit, meaning those two operations will be performed as a single transaction. If there is a problem in any of those operations, then SQL exception will be invoked. At that point, you might want to actually roll things back. Let's see. Okay, transaction isolation levels. Okay, so isolation levels are four isolation levels. So read uncommitted and serializable. So isolation and the performance they actually are the opposing goals. Isolation provides the acid property. Well, the isolation actually provides a way of being independent from the other transaction. So, and the performance is also actually you get the higher. So, the more isolation you get, like a serializable, providing the most highest level of isolation, meaning every transaction will be performing in sequential manner, which will not be actually, well performing. So this is the lowest performing behavior, but it actually provides highest level of isolation. Okay. And this one is the lowest level of isolation, but it will actually provide the best performance. Okay, so let's talk about each of these in a bit more detail in the following slides. So let's start with the read uncommitted. So read uncommitted isolation level causes what is called the dirty reads symptom. What it means is that uncommitted changes in one transaction, like in this case, client 1 and client 2, is visible in other transactions. So let's take a look at that. So let's say the client 1 start the transaction and client insert a record A. Okay. Now in this read uncommitted isolation level, the client 2 actually sees this record. And it's called the dirty record. The reason is because if client 1 rolls back, then that record is not there anymore. Okay, so in that case, this client 2 is not going to see that record anymore. Okay, so this is basically seeing a dirty read. Okay, all right, so this is the read uncommitted isolation level. So lowest level isolation, but provides the best performance. Okay, so the next one is read uncommitted isolation level. So in this case, committed updates in one transaction is visible within another transaction. So this is a case. So client 1 start the transaction, insert record A. Now this one doesn't see that until the first one, client 1 is committed. So this is actually better isolation than the previous one, right? In previous one, you were able to see it as when the client 1 actually insert the record. Okay. Now, when the client 1 is committed, then if client 2 performs a query operation, now it sees it. So in this case, in a single transaction, there could be different behaviors, different, the result. Okay, so here it doesn't see it because client 1 does not commit the change insertion. Now, after commit, it sees it. So two different behavior in a single transaction for the client 2. Okay, so this is read committed isolation level. The next level is repeatable read isolation. So in this case, so by the way, this is the default isolation level for DB tables and the other database. So in this case, within a transaction, all reads are consistent. So here in transaction client 2 is not going to see until itself is committed. So in compared to the previous one, in previous case, we were able to see as soon as the client 1 is committed, right? But here it's not going to see until itself is committed. Okay, so here insert 1 is committed, but it doesn't see it until it commits it, and then it sees it. Okay, so this is repeatable read isolation. And serializable isolation is the highest level of isolation, but it provides the worst performance. Okay, so transactions are serialized. So what it means is that until previous transaction is done, meaning either commit or rollback, the database operation in other transactions are blocked. So suppose the client 1 insert a record, and until is committed, when it's trying to read the database, it will be blocked. Okay, I mean table, it will be blocked, and when it is committed, then it will be able to continue. Okay, all right. So that is the serializable isolation level. Okay, so that's the end of the presentation. Now let's take a look at the hands-on lab. So exercise 1 is you want to configure your Java JDK, you want to actually Java JDK Java doc so that you can actually have a context sensitive Java docking on JDBC APIs. Okay, so because JDBC APIs are part of the JDK, all you have to do is JDK 6 doc, okay, to configure. All right, exercise 1. Now you can use either MySQL server or DataDB Java DB server, and I provide both applications. One version for MySQL, the other version for Java DB. So you can open one of those, and then you're going to create a copies table, and then you're going to insert rows to the copies table, and you can perform context-sensitive Java docking, and then you can print the columns. So I'm going to just demonstrate this one quickly, and then we are going to actually use the documentation for explanation because it has highlighted code. Okay, so now I am running JDBC samples and Java DB, and I'm already running Java DB right now. Okay, so I am going to call create copy table. So we don't have any create copy table yet. Okay, so create copy and run the file, and we are creating. So now coffee table is successfully created. Okay, so if you take a look at the code, so here we are creating. So we are actually registering this client driver to the driver manager. Okay, and then we are creating a connection object by calling get connection method from the driver manager. And then we create a statement object, and then we actually basically perform execute and update. Okay, so create string is basically we are creating copies table with these columns. Okay, coffee name, supply ID, price, and sales and total. Okay, and then we are just closing and statement and connection. Okay, pretty straightforward. Now, what we are going to do is we are going to now insert rows to the copies table. So we are going to call insert copy.java code. So we have insert copies. So right click it, run file. So now we are adding rows to the copies table. So we can actually take a look at the copies table. So this is samples. Let's make a connection. So we can take a look at tables, and we have a copies table. If you see the rows, yeah, okay. So we are seeing multiple rows, 5 rows, okay, and that's basically what we are seeing in the code. Okay, so insert code, we are basically performing 5 execute update insert operations. So we insert 5 rows. Okay, and then we get the execute query operation, and then for each rows, so we call rs next first, and for each rows you're just getting the coffee name and just price information, and that's what we displaying it. Okay, right here. So Colombian is 7.99, French toast is 8.99, and things like that. And the next one is so we insert rows to copies table, and you can actually also perform context-sensitive Java documentation. So if you want to actually see result set Java API, right-click it and show Java doc, and you should be able to see Java docking. Wait a minute. This is statement. Oh, looks like I haven't actually configured the Java doc. Let me just set the Java docking, Java platform information. And Java doc, it is there. I'm not sure why it didn't work. Try string. Oh, looks like I have some issues with the Java docking. All right, so yeah, I have to actually restart the NetBeans or something like that. Okay, so next is the print table columns. So we actually now using the meta information. So this is the result. Okay, so print columns.java. If I run the print columns.java, yeah, like this one, and one file, and yeah, you're seeing this information. Okay, column 1 is JDBC type is 12, and then this is the supply ID, price, sales, and total, and all that stuff. Okay, so the code is, again, we are actually getting the print columns. I'm gonna actually see print columns. Yeah, so you're getting the metadata on the result set, and we're just displaying the names of the columns and all that stuff. Okay, yeah, so display the column names, and then we display each rows of the table, and that's what you see here. Okay, so that's that. And exercise 2 is exercise basic JDBC functions with a join table. So this is the case, basically you are creating a select join statement, okay? And the usage of the string, and then you can just perform execute query, okay? Nothing really complicated. And exercise 3 is the batch update and the scrollable result set and database metadata and parameter metadata. So let's take a look at the batch. So here, the batch update is that you can create a single statement that contains with in this case, a statement is a batch of statement. Okay, so basically you are calling add batch for this and this and this and this. So by performing just one statement, you're actually adding 4 rows into the table. So this is a lot more efficient. Okay, so this is a batch. Okay, and this is a scrollable result set. So here you can specify when you create a statement, you can say result set type scroll sensitive. Okay, and you can also set the relative value and absolute value. And yeah, so this is the database information, so you can find out the information about the database. So again, this is actually database metadata information you can get. And parameter metadata. Yeah, so each parameters. This is the prepare statement exercise. And exercise 4 is a transactional behavior. Okay, so here we are setting auto commit to false, and here we perform the 2 operations, right? And then you are performing commit for each of those 2 operations. Okay, and then you are actually setting set commit to true again. Okay. Let's see, and the type concurrency. Let me see the data source. Yeah, okay. So data source. So data source is something in the app server environment. You can actually create a data source object that represents a connection pool. Okay. All right. So here, just if you're using Glassfish, JDBC sample, JDBC resource are already set, so you don't have to actually create one. If you want to actually create a brand new data source, then you have to actually go to the admin console of the Glassfish and create one. So you can check. So just check whether this is already created. So if you actually see services and servers, and so here resources. So we have these JDBC data sources have been already created. Okay, and so yeah, you can check the this JDBC sample JDBC resource from the admin console as well. So you go to Glassfish23 admin console, and you logging in, and then you should be able to see. Why don't I actually do that? So here, let's go to the services, and let's take a look at the admin console. Question from Deparani. Batch statement is the same as a prepared statement? No, they are different things. Batch statement is a collection of statement. Prepared statement is the statement that has been already compiled. Okay. So let's see if I want to see the admin console. Okay. So this is the JDBC resource. So I can see JDBC resource, and the one that we are actually using is the JDBC sample that has been already created. Okay. All right. So it's actually sample pool and all that stuff. Okay. So let's see the. So in this case, we have a sample application, web data source Java DB project, and when you run the application, you get this result of performing SQL operation 1, and you can actually take a look at this table that's involved. And the code is, yeah, so the way that you are going to get the data source object is from the initial context object, and then you are going to perform a lookup operation like this, and you get the data connection object. And from the data connection object, you get the data source object, you get the connection object. Okay. Or in Java E6, you can actually use the injection scheme, like you can say, resource, add resource and data source, and and things like that. Okay. All right. So exercise 6 is for using stored procedures. In this case, we are using MySQL. Okay. So again, this is the way that yeah. So this is the person data SQL. Again, this is from the uh, yeah, so on the scripts, and yeah, so we actually test the table, and then we actually creating a procedure, create school table, and drop school table. So this is the way that you're going to create a procedure, stored procedure on MySQL. Okay. And then you're actually executing the SQL. So you're actually creating a stored procedures. So these are the uh, creating a database, the stored procedures, and you actually executing person in. Yeah, so basically we are calling the stored procedures like this. Okay. And so this is the way that you are going to actually, create a stored procedure and execute those stored procedures at the MySQL, the shell. Okay. So in this exercise, basically seeing those stored procedures, and then you are going to use JDBC APIs to call that stored procedures. Okay. So the stored procedures you are going to call is like this. This is something that we have created in previous steps here. Okay. We created these stored procedures, and the way that you're going to call these stored procedures is CallableStatement. Okay. All right. So these are all examples of the stored procedures that we have created. All right, so that is the end of the presentation. Again, I apologize for being late on today's webinar. So let me just